Hello everyone, I am Shreya from Analytics Jobs and I am here today to talk about some quick facts about linear regression and logistic regression. Before starting, do not forget to subscribe to our channel and hit the bell icon so you do not miss any informative update from us. Let's now have a quick view on where these terms actually come from. Linear regression and logistic regressions are different machine learning algorithms. Machine learning, a part of artificial intelligence that uses various algorithms to enable a system to learn from the training data rather than learning through explicit programming. If you haven't checked our video on what is machine learning, do check it out, link of which is given in the description box. Now let's take these two terms separately. Linear regression. As said, linear regression is an ML algorithm based on supervised learning. It performs a regression process based on independent variables, regression models, a target prediction value. It's normally used for finding out the connection between forecasting and the variables. Different regression models differ based on the relationship type between independent and dependent variables they are considering and the number of independent variables being used.
For instance, standard form of linear equation ax plus by equals c. This equation must be converted into slope-intercept form, that is y equals mx plus c for easy graph implementation. Another form of equation for a line point slope form y minus y1 equals m x minus x1, where the slope m is defined and xy are the variables. If x1, y1 are the points on the line, then slope equals dy by dx equals y2 minus y1 upon x2 minus x1. Note that parallel lines have equal slopes.
Now, important points to remember in linear regression are: there must be a linear relationship between dependent and independent variables. Multi-regression suffers from autocorrelation, heteroscedasticity, multicollinearity. It is very sensitive to outliers. Outliers can terribly affect the regression line and also forecasted values. The difference between simple and multilinear regression is that multilinear regression has more than one independent variable, whereas in single linear regression, there is only one independent variable. In the case of multiple independent variables, we can go with a stepwise approach, forward selection and backward elimination. Logistics regression. After linear regression, the most famous machine learning algorithm is logistic regression. There are lots of classification tasks done regularly by people. For instance, classifying whether an email is spam or perhaps not, classifying if a tumor is benign or malignant, classifying whether a website is fraud or not, etc. These are common situations where machine learning algorithms are able to make our lives a lot easier. A very simple, useful and rudimental algorithm for classification stands out as the logistic regression algorithm. It is a supervised learning classification algorithm used for predicting the probability of a target variable. The dependent variable is binary in nature, having data coded as either 0 or 1. Types of logistic regression. Number 1, binary or binomial, and number 2, multinomial. As said, number 1, binary or binomial logistic regression. In this regression, a dependent variable can have only two possible results, that is either 1 or 0. There should be no outliers in the data. There should be no chance for high correlations among the predictors. These variables are used to represent win or loss, yes or no, and success or failure. Number 2, multinomial logistic regression. In this regression, a dependent variable can have more than two possible outcomes or the types representing quantitative significance. The variables can represent type A, type B or type C. Important points to remember in logistic regression are: it is widely used in classification problems. It doesn't require a linear relationship between independent and dependent variables. It can also handle various relationships because it uses a non-linear log transformation to predict odd ratios. All significant variables must be included to avoid fitting and underfitting. It requires less input data. The independent variables shouldn't be correlated with one another, that is, simply no multicollinearity. However, we have the option to include the interaction effects of categorical variables in the analysis and in the model. If the dependent variable is ordinal, then it is known as ordinal logistic regression. If the value of dependent variable is multi-class, then it is known as multinomial logistic regression. In many ways, logistic regression and linear regression are similar. However, the difference lies in what they are used for. Linear regression algorithms are used for predicting or forecasting values, but logistic regression is used in classification tasks. So this is it for today. I hope you find this video helpful. Comment us your queries and suggestions, and don't forget to share the video with your fellows. Stay healthy.